Let me record this. All right, so we want to count the number of bit strings that have of length n that do not contain two consecutive zeros. Yeah, I think we had this earlier. So for example, we have 2 here, we have 5 of that strings, namely 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, and 1, 1, 1. Now then, can you, now the next part is to guess the pattern, right? But be careful here when you guess the pattern, you have to show that the pattern indeed holds. For that, that means you have to have some argument, right? So the idea here is, okay, let's guess the pattern here. So for example, you see that A3 is equal to, A3 here is equal to A1 plus A2. So you may wonder whether A4 is equal to A3 plus A2. Now let's check, right? So what is A4? A4 contains how many? So let's count, right? So what are the strings for A4 that do not contain two consecutive zeros? Yeah. Well, let's start with the one starting with 0, right? So 0, then the next one cannot be 0, right? It has to be 1. And then of course the next one could be 1 or 0, right? So therefore, if it is 1, if it is 0, then the next one must be 1, right? Again, so we start again with 0, right? 0, the next after 0 it must be 1, otherwise we have two consecutive zeros, right? Then we have 1, yeah, and after 1 it could either be 0 or you could have this. Those are the strings that have start with 0, right? So what about the strings that start with 1? Can you help me? If I start with 1, what are the possibilities for the next number?
0, 0, 0.
0, 0, 0. Are we counting this? Remember?
Oh no, we don't.
So what do you think?
0, 1, 0.
0, and then 1, and then 0. Okay.
0.
What else? Let's start with 1 again.
0, 1, 1.
1, 0, 1, 1. That is correct. Yes. Now, are these the only ones? Maybe we have more, right?
Yeah, we have more.
For example, what?
1, 1, 0.
1, 1, 0, and then
1.
1. Okay. Is that it? Do we have more?
1, 1, 1, 0. 1, 1, 0.
1, 0. Correct. Do we still have more?
All
Yes.
1.
Yes. Great. So that's how we approach it, right? So we look at the cases, yeah. Okay. Now, so how many bit strings are there here?
8.
8. Wow, that's interesting indeed. Actually, this is actually 5 plus 3, right? Which is A3 plus A2, right? Now, maybe we have that actually AN is AN minus 1 plus AN minus 2. Yeah, which is what we have here. Yeah. Now, of course, you want to say, first of all, for this equation, this relation to hold, this has to be well defined, right? Well defined. And this also has to be well defined, right? So that means, for example, at least we must have how many initial values? We must have, at least we must have two initial values. Yeah, for example, either you could start with A0 and A1, or for example, A1 and A2, for example. Now we must have, now these values are defined, are predefined. Right? Now this relation is called a recurrence relation. So why is it called recurrence? Well, because it uses the terms in the sequence, right? Yeah. Now our aim here is to solve the recurrence relation by finding an explicit formula for an. What is an explicit formula? What is explicit formula? It is a formula without using the other terms in the relation, in the sequence. That is, an is a formula. So you want to find a formula such that an is equal to something, where this something does not contain an minus 1, does not contain an minus 2, does not contain a2, does not contain a0, and so on. Yeah. So it's an explicit formula. We'll see an example later. Now here's an example of another recurrence relation. I think this is also quiz number, was it quiz? The last week's quiz question what? I don't remember which question. Yeah, I think one of the question last week's quiz, right? So how do we approach this problem? So can you guess how do we start this, solving this? Anybody? So how do we solve this? So let's start with A0, right? So the n here is the month, right? So let's start with month. Yeah. After n month. So let's do it this way. Let's do it this way. So n is the month, and then we have after n month. Number of rabbit, right? Number of pairs of rabbit. Yeah. After the 0th month, how many pairs do we have in the island? Hello, everybody. One. Only one pair, right? So how do we get one? Well, it's obvious, right? So because we only have this pair of young rabbits here. Yeah. After 1 month, how many pair of rabbits do we have in the island?
No one.
Still one. Okay, great. Still one, right? Yeah. Now after 2 months, how many?
Pairs.
What is it, Rafael?
2 pairs.
2 pairs, correct. Yeah. So let me note this down, right? So let's use the pair xy as the pair, right? This is xy. This is xy. Yeah. Now we have 2 pairs. That means this xy. We assume rabbits live forever. So the xy from the previous one is still ours. The pair is still there, and it produces another pair, so another xy. Yeah. So 2. Now, what about after the 3rd month?
Still 2.
Okay, let's count. Why is it still 2?
Never mind. 3, 3.
3. So how do you get 3, Rafael?
The first pair made another 2.
The first pair made another 2. What do you mean? It only produced one.
The first pair made breed another pair.
The first pair bring another pair. So you mean this one? And then?
Yeah. The second pair is still 1 month old.
Okay, good. Yes. Now, so we have 3. What about after 4 months?
Five pairs.
Yes, 5. How do we get 5? The 3 pair.
The first pair made another one, and then the second pair became 2 months old.
So how do we get 5? So those are only 2 pairs, right?
Because we made another 2 pair.
Okay, here is how we work. Okay, thank you, Rafael. But this is how we do it systematically, all right? So first, we look at the existing pairs, all right? What happened to the existing pairs? What will happen to them? Well, they live forever, so all those 3 pairs are still there, right? So that means we have these 3 pairs still there. And then out of these 3 pairs, which of them are 2 months old? Or at least 2 months old?
The first and the second pair.
Right, this one, and then this one is now 2 months old, right? Or let me do it this way. So let me mark with the green underline if the pair is 2 months old at the end of the nth month. All right, so that means this one and this, right? So now, yeah, then this one, oops, sorry. Yeah, now this one is 2 months old. Yeah, so therefore, yeah, now we have this and this 2 months old. So and this is not at yet 2 months old. So that means they produce, each of these pair produce 2 more pairs. All right. What about the end of the 5th month? Well, let's write down the pairs, right? This one, this one, this one, and then this one, and then this one. Right now, which one is at least 2 months old? Well, this, and of this one is 2 months old, right? So we add 3 more pairs. From which we get 1, 2, 3, 4, 5, 6, 7, 8. Now, of course, you could guess that actually after 6 months we have 13 pairs. Yeah, and so on. So the argument is like this, right? So let AN be the number of rabbit pairs rabbit pairs after n month. So after, so we have how many pairs of rabbit initially? We have only 1 pair, right? So 1 pair initially. so after 0 month, 0, 0 and 1 month, we only have that one pair, right? Yeah, so a0, which is equal to a1, which is 1. Now after 2 months, so after 2 months, that pair produce another pair, right? So that means a1, so a2 is 2. Yeah. Now after 3 months, yeah, after 3 months, you only have one pair, yeah, that is at least 2 months old, right? Yeah, we only have one pair. Age at least 2 months old. Yeah. The other pair is still too young. Yeah. So therefore, A3 is actually, well, the previous 2 pairs is still there because they live forever, plus another new pair, right? So it means 3. Now that means we could write after n months, or we could argue, right? So after n months, yeah, the number of rabbits, number of pairs, is obtained by the pairs after n minus 1 months, right? Yeah. Plus the pairs produced by pairs at least 2 months old, right? Age to at least 2 months old, right? Now these pairs yeah, how many of these pairs? Well, it's the pairs we have after n minus 2 months, right? Because only those pairs that we have after n minus 2 months would age at least 2 months old. So we have an minus 2 such pairs, hence an is equal to an minus 1 plus an minus 2. All right. Any question? So we have our recurrence relation is an minus 1 plus an minus 2 with initial condition a0 is equal to a1, which is 1. Or let me write down better so that you don't confused. A0 is 1, and then a0 is 1 and a1 is also 1. Right? Any question? No? If not, then let's have a look at another example. For some reason, when I compile the file, the figure, the pictures does not show here. There should have been a picture like this. So we have 3 packs, yeah, and then we have round packs. Like we have 3 poles. Sorry, we have 3 packs, and we have this. So for example, if we have 1, 2, 3, 1, 2, 3, 4, 5, 6. So we have 6 discs, for example. It will be this was this, and this is the second disc, smaller, and then smaller, and then smaller, and then smaller. Yeah. So you put this on the pack. Yeah. So how many steps are needed to move all discs from pack 1 to pack 3 such that a disc is never stacked on top of a smaller disc throughout the process of the moving? So how do we move such disc? If we have only 2 discs, this is pack 1, pack 2, this is pack 3, all right? If we have only 2 discs, how do we move them? Okay, let's start with the even easier one. So if we have only 1 disc, how do we move that? How many steps do we need?
1.
1 step. Matthew, thank you. Well, it's easy, right? We simply move that disc from the first pack to the third pack, right? Yeah. Now, what if we have 2 discs?
3.
Okay. How do we get 3, Rafael?
So we put the small one in the middle, and then the bigger one on the third one, and then we move the smaller one to the third one.
Okay, good, very good. So let's call the disc. Let's call the D0 this, yeah, the disc. Let's call it D0, D1, not D0. Let's call it D1, D2, D3, up to DN. Yeah, where the size, yeah, let's call it the size is D1 is less than D2, less than D3, and so on. Yeah. So that means the 3 step here is move D1 from pack 1 to pack 2, and then move D2 from pack 1 to pack 3, and then move D1 from pack 1 from 2 to pack 3. Right? Now, what about if we have 3 discs? What are the moves? Move disk from 2. Okay. We have, but that means we have D1, D2, and D3. So what would be our step? We have 3 disks. Anybody has an idea? How do we have 3 disks now? Hello? No one? What will be our first step? Which disk do we move?
The smallest one.
Which is this? Which disk?
Disk 1.
D1, right? From
from pack 1 to pack 2.
2. Okay. Okay. Then
D2 from pack 1 to pack 3.
D2 from pack 1 to pack 3. Okay.
And then D1 from pack 2 to pack 3.
D1 from pack 2 to pack 3. Okay. And then
And then D3 from pack 1 to pack 2.
2. And then
D1 from 3 to 1.
3 to 1. And then
D2 from 3 to 2.
okay. And then
Never mind, I think I'm already wrong.
okay. The aim is to move from pack 1 to pack 3. So how do we fix this?
From when I move
Should have been
from when I move to D1 to from 2 to 3. So first D1 from 1 to 2, D2 from 1 to 3,
Mhm.
D1 from 2 to 1,
D1 from 2 to 1.
and then D2 from 3 to 2,
2 from 3 to 2.
D2 from 3 to 2,
Or D2 from 3 to 2.
and then D1 from 1 to 2,
1 to 2.
and then D3 from 1 to 3.
D3 from 1 to 3. And then
D1 from 2 to 1,
2 to 1.
D2 from 2 to 3,
D2 from 2 to 3.
D1 from 1 to 3.
1, 2, 3. How many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we have 9 steps. We could actually do it in 7 steps. How? Well, this is my steps. Yeah. Instead of this, you have 9 steps, right, Rafael? So let's do it in 7 steps.
Okay, sir.
So here, instead of moving from 1 to 2, move it from 1 to 3. And then D2, let's move from 1 to 2. And then now I move D1 back from 3 to 2. Okay. Now I move D3 from 1 to 3. And then D1 from 2. Yeah, from 2 to 1. And then D2 from 2 to 3. And finally D1 from 1 to 3. Is that correct?
Yes, sir.
Yes. Okay.
Sir.
So you took like a longer route, yeah, Rafael. But we actually could do it. So now, if I say, if I want to move 4 disks, so I don't have to write down all the steps. But what is the idea if I want to move 4 disks from 1 to pack 1 to pack 3? Let me draw the pack better. Yeah, bad. Yeah. Okay. What is the key idea if you want to move 4 disks from pack 1 to pack 3? What will be our general step? What is your strategy, general strategy? Can anybody guess? Well, nobody?
No, sir.
Okay, so let's consider for this. All right, so we have for this. Yeah, what is the main thing for this for this to be moved from pack 1 to pack 3? Well, obviously, the largest disk, right? The largest disk must be moved from pack 1 to pack 3, right? That is the key part, right? You have to do that first before you move the remaining disk to pack 3. Yeah? Yeah? Is that, can you see that?
Yes.
So that, so we need, so let me put it here as the step. We need to move the largest disk from pack 1 to pack 3. Now, in order to move the largest disk from pack 1 to pack 3, what do we need to do before doing that?
We need to stack the remaining in pack 2.
Correct. So that is correct. Thank you, Matthew. So we need to move the 3 smaller disks from pack 1 to pack 2, right? Yeah. And of course, at the end, we move first the 3 small disks from pack 1 to pack 2. Well, you went, so we cannot, but we cannot move 3 disks. We cannot move 3 disks at the same time, right? But we could count the steps, right? So let's finish the strategy first. So the first strategy, so the strategy is first to move the 3 smaller disks from pack 1 to pack 2, and then followed it by moving the largest disk from pack 1 to pack 3, and then we finish it by move the 3 smaller disks from pack 2 to pack 1, pack 3, sorry. So now let me ask, how many steps? For this, and this. Well, the easiest one. How many steps for the second part here? How many steps? One step, exactly. So this one step. Now, how many steps for the first part? How many steps for the first part of the strategy? So let me give a number here. So this is number part, step 1, step 2, step 3, right? Sorry, part 1, part 2, and part 3. Now let's consider part 1. Part 1 here, yeah, is the same as the number of moves, the number of steps, moving 3 disks from pack 1 to pack 3. Is it the same? Is it the same? So moving 3 smaller disks, moving 3 disks. Let's ignore whether we have the bigger one. But let's if we only have 3 disks. If we only have 3 disks, move the number of steps to move 3 disks from pack 1 to pack 2 is exactly the same as the number of steps to move those 3 disks from pack 1 to pack 3. Is that correct, or is this true or false? So can anybody give me an answer? Is this the same or not? Okay.
I think yes.
Okay. Matthew, can you explain a bit more? Why yes?
Because it's with n with 4 disk, you try to move the 3 disks to peg 2, right?
Yes.
I don't know. I'm just guessing.
Okay. That's all right. So okay,
I think
let's
it's the same.
start from if I only have one disk. I only have one disk, all right? If I only have one disk, the number of steps I need to move that one disk from peg 1 to peg 3, is it the same as the number of steps of moving that one disk from peg 1 to peg 2?
Yes.
Yes, exactly, right? Now, what if we have two disks? Do we still have the same thing?
To move the one
Yeah,
disk
to be
to
the
peg
number of
2.
steps to, yeah, the number of steps moving
Yes, still
two
the
disks.
same.
Yeah, two disks from peg 1 to peg 3 is the same as number of steps moving two disks from peg 1 to peg 2, right? Now, 3 steps is moving 3 smaller disks is also the same, right? Why? Because here it doesn't matter which numbers do we have actually, right? We could, of course, we could instead of peg 1, peg 2, and peg 3, I could say this is peg 1, this is peg 2, and this is peg 3, right? The same thing, right? So, or we could just, moving the pegs around, right? So it's the same, right? That means, yeah, that means this is, or part 1 is the same as the number of steps of moving 3 smaller disks from peg 1 to peg 3, yeah? So, or if I want to take more general, let's use it this way. Let's call it one peg as the target peg, and the other peg is the temporary, intermediate peg. All right. Now, if we look at that way, then it's obvious, right? So let's say the target is 3. I mean, if the target is peg 3, you start from peg 1 here, then the intermediate peg has to be peg 2, right? So moving, or if now the target is peg 2, then the intermediate peg could be peg 3 if you move it from peg 1. So therefore, moving 3 smaller disks from peg 1 to peg 2 is essentially consists of moving 2 disks from peg 1 to peg 3 first, and then moving the biggest of the 3 to peg 2, and then moving the 2 disks, 2 smaller disks from peg 3 to peg 2. All right. Yeah. So that means we need how many? Well, this has to be 7. And similarly, this has to be 7. Yeah. So in total, we have 15 steps. So any question? So now if we have n disks, yeah, that means, yeah, let's call it Hn is the number of steps to move n disk from peg 1 to peg 3, yeah, or not peg 3, right? So peg from peg source to peg target, let's call it that, from the source peg, from the source back to target back. Yeah. So say that means Hn consists of, we need Hn minus 1 step, yeah, to move n minus 1 smaller disk from the source to the target. Sorry, the intermediate, yeah, steps to move. Let me erase my notes above here, right? So let me erase it here. Yeah. So Hn is, we need Hn minus 1 steps to move n minus 1 smaller disk from pack 1 to pack 2, and then plus 1 step to move the largest disk from pack 1 to pack 3, and then plus Hn minus step again, Hn minus 1 step again to move n minus 1 smaller disk from pack 2 to pack 3, right? So that means Hn is Hn minus 1 plus 1 plus Hn minus n, Hn minus 1, which is 2 times Hn minus 1 plus 1. Right, now what is the initial condition? Well, let's call it H1 is 1. Yeah, because we only need 1 step to move 1 disk from pack 1 to pack 3. Any question at this point? So not that H1, then we have H1 is 1, H2 is, as we saw, it's 3. Yeah. And then H3 is, of course, 7. Yeah. Sorry, H2 is not 2, it's 3. Sorry, 3, 7, and H4 is 15, and then H5 is actually 31. Yeah, you could of course guess that actually Hn is in fact to the power of n minus 1. Now this form is the explicit formula. Yeah, this is called the explicit formula. Yeah. Now in this chapter, our aim is to, first, you're given a problem, try to model it as a recurrence relation, and then you are asked to solve that recurrence relation to get an explicit formula for that relation. So let's have another example here. Now, what about this one? Suppose I have pin numbers. Pin numbers here consist of n decimal digits. So that means the digits could be 0, 1, 2, up to 9. And we have n of them. So n digits. So for example, maybe your ATM card, your debit card might have a pin consisting of 6 decimal digits. Yeah. Yeah, in many banks, you use 6 decimal digits. Yeah. Of course, in this particular example, we only allow certain pins. So we only allow pins, we only allow valid pins, namely the pins that contain an even number of zeros. Even number of zeros. So, how many valid pins of length n are there? So here's what we do, right? So let an be the number of pins, the number of valid pins, I should say, of length n. So let's start with A0. A0 is what? How many valid pins of length n?
0.
Is it 0? Really? Okay, maybe someone say, well, pins cannot be like 0, right? So then what's the point of pin? Okay, let's start with A1 then. Yeah. So with A1 then. What is A1? How many valid pins of length 1?
0.
Really? Why is it 0? So all pins, yeah, all pins of length 1 are not valid.
Is it 9?
Yes, actually it is 9. Why, Matthew?
Because if the digit is other than 0, then the number of 0 is 0 and it's even.
Yes, exactly. So A1 is 9, not 0, right? Because if A1 is, because so we could simply enumerate them, right? So what are the valid pins? Okay, let me start with the all pins, right? What are the possible pins of length 0? Sorry, of length 1. Pins of length 1. There will be this, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, Rafael, which one of these are not valid?
Sorry, what, sir?
Which one of these? So we have how many pins of length 1?
Oh, we have 10.
10, right? So out of these 10, are all of them not valid, or only which one is not valid? Which one is valid? Which one is not valid?
From 1 to 9.
Yes, 1 to 9 is valid. Yeah, it's valid. This one is not valid. Yeah. Now, what about A2? What do you think? What about A2? Pin of length 2. How many of them? How many possible pins of length 2?
11.
No, how many possible pins of length 2? It could be from 0, 0 up to 9, 9, right?
100.
So yes, 100 of them. Now, which of them is valid? Or let's rule out the ones that is not valid.
10.
Not valid would be, what are they?
10, 20, 30.
Well, oh yeah, 1, 0, 2, 0, 3, 0, up to 9, 0. Is that it?
No, 0, 1.
Correct.
02 until 09.
Correct. So how many of them not valid?
18.
18. Yeah. So that means valid of length 2 is, well, 100 minus 18, right? Right? 100
Yeah.
minus
Yes.
18. So that is 80, 82.
82.
Let's check. Yes, 82. Yes, 82. What about A3? Now it's getting more complicated, right? What about A3? It's actually uh, it's actually it should be 756. What? How do we get this? Well, let's analyze this, right? So if you see if you look at the numbers, it's hard to see the pattern, right? So how do we get this, right? So let's do it this way. So we model it this way, right? So if we have an, yeah, and the number of valid pins of length n. So the question is, yeah, how do we construct a valid pin of length n? Well, first, our first part, we know that valid pin of length n, yeah, yeah, can start with a 0, right? Yeah, or let me write it down here. Let's do it here. So let's write it down. Suppose X is valid pin of length n. Yeah. Case 1, X begins with
Zero.
what? Begins with 0, right? Begins with oh no, let's do it this way. I think this is easier rather than that. Let's start with n's. X ends with digit other than 0, right? That is X is equal to y1 or y2 up to y9, right? Yeah. So, and here y, now if X is ended with a digit other than 0, then y, yeah, is y a valid, is y a valid pin? So let's check, right? So y is of length what? Y is of length what? If x is of length n, then y is of length
M.
x is of length n, Rafael. And now we know that x is equal to y followed by 1 or y followed by 2 or or y followed by 9. So y must be of length
1. N minus 1.
correct, n minus 1. Yeah. So y is of length n minus 1. Now the question is y valid? Is y a valid pin? Is y a valid pin or not? Does it contain an even number of 0?
Yes.
Why?
Because y isn't 0.
How do we know y is not 0? Okay, let's give an example. All right. Suppose I have this pin, blah, 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 and followed by 9. I know that the whole thing here is valid. Now, if I only take this part, is it also valid? Or does it contain even number of zeros?
Not sure.
Why not sure? You know that the whole thing is valid. The whole thing is valid, then it contains an even number of 0, right?
Yeah, oh, it's valid. It's valid because
Yeah.
the number other than y is 1 to 9, not 0.
Yes, correct. So is y valid? Then the answer is yes, because x is valid. Yeah, x is valid, and then y is just and y is just x is part of x except the n, right? And the n of x is not 0 in this case because x is valid. Yeah. So the even number of zeros, the even number of zeros must also be in x, and thus must also be in y, correct? Yeah. So now that means from here we get that how many of them? Yeah. We have how many of them? Well, 9 times a n minus 1, right? Yeah. How many of such y is there? Well, there is 9 times a n minus 1 of such y, right? Now the second case is x ends with 0. So that means, yeah, no, we have to be careful, right? Now, yeah, if x ends with 0, then x is equal to y0. But here in this case, y may not be valid, right? May be valid or maybe not, right? Because y may contain, yeah, may contain an even number of, yeah, sorry, let's put it this way. Y cannot be valid. Yeah, Y cannot be valid because if X is valid, then X has even number of zeros, then Y has how many number of zeros?
Odd.
Yeah, has an odd number of zeros. So Y cannot be valid, right? So that means, and we know that Y, so from here we know that the number of such X is equal to the number of such Y, right? Now, how many such Y? How many such Y? You know that Y cannot be valid. Yeah, Y is not valid. Is not valid. And then also Y is of length n minus 1, correct? So how many such Y's? Well, of course, right? So because if Y is not valid and Y is of length 1, now how many such Y's? Yeah, it's equal to number of all pins of length n minus 1 minus the number of valid pins, right? Of length n minus 1. Is it correct?
Yes.
Yes. Okay. Any question here before I finish this example? Is it clear? Or do you have any question? No question at all. Okay, so that means how many of them? This is equal to what? Can anybody help me? How many pins of length n minus 1 overall? Not just the valid one, but all pins of length n minus 1. How many of them? How many pins of length 3 overall?
Length 3 would be 10 to the power 3.
Correct. So how many pins overall of length n minus 1?
10 to the power of n minus 1.
Correct. 10 to the power of n minus 1. Minus what? Here. Here. Minus the number of valid pins of length n minus 1. Let me use the red. Minus what? How many valid pins of length n minus 1? You don't know yet?
An minus 1.
Correct. So that is exactly right. So an minus 1. So if we combine them together, we have that actually an is this one. Yeah. And this one. which is, of course, 9an minus 1 plus 10 to the power of n minus 1 minus an minus 1, which is, of course, well, 8an minus 1 plus 10 to the power of n. Now, what is the initial condition? Well, we know that a1 is 9. Yeah. Any question here? Anybody? Any question?
No, sir.
No. Shall we do more examples from the quiz? Let's have a look at last week's quiz. We haven't talked about it, right? We haven't finished it at all, right? We haven't even discussed it. So, all right. So, not this one. All right. So let's. Okay, let's do it here. Oops. Hold on a second. That section. 1, 2, 3, 4, and 5. All right. So this quiz week 4. Yeah. So let me share this. So, all right. Now, let's have a look at week 4. Let's start with this question. Apologize, there's some issues with my mouse. Let's try it again here. Here it is. All right, so let me enlarge this. Oops. All right, so this one is rather easy, should be. So what is the solution here? Anybody? The first 5 terms, so A0 up to A4. What are they? Let's go through it together, shall we?
1,
1,
2,
2, and then
8,
8. So 6 plus 2, right? So 8. And then
Wait a minute, sir. 28.
28 and
100.
100, right? So 84 plus, no, is it 100?
Yeah, it's
Yes.
84 plus 16.
3 times 28 is 60 plus 24 is 84. Yes, yes, 84 plus 16. Yes, it's 100. What about this one? A0 is 1. Yes. What is the next one?
Minus 1.
Sorry?
Minus 1.
Minus 1. So minus 2 times 1 is minus 2 plus 3 to the power of 0, which is 1. Minus 2 plus 1. So it is minus 1. Yes. What about the next one?
5.
2 plus 3. Yeah, 5. And then
Minus 1.
minus 10 plus 9, which is minus 1. And then
29.
2 plus 27, which is 29. Yes. Good. Now, what about this one? We have minus 1 and we have 1 and then
1.
1. So it's 1 minus 2 plus 3. No, plus 2. 1 minus 2 plus 2. So it's 1. Yes. What's the next one?
6.
So 1 plus 2 plus 3, 6. And then
16. 12. Sorry.
12. Yeah. So you have 6 plus 2 plus 4, which is 12. Yes. Good. Now, what about this one? A 0 is 0. A 1 is 1. Now, what about a 2?
Minus 2.
So minus 2. Yes. And then
7.
7. And then
Minus 20.
minus 14 plus minus 6. So minus 20. Yes. Now, what about this one?
1,
2.
2,
And
1.
then it's 2 plus 2 times 1 minus 2. Hold on a second. 3 times 1 minus 2. So it's 1. Yes. And then
6.
3 times, so it's 3 plus 1. So 4 times 2 minus 2, which is 6. And then it's 5 times 5. 5 times 1 minus 2, which is 3, right?
Oh, yeah.
So that is 1. And then what about the next one? So let's do it here. All right. Now what about this one? So let's check a second. Now so let's do it this way. All right. Oops, I'm sorry. Something is wrong. Oh no. All right, so we could enlarge this. Now, which of the following equation represent the same sequence as an? So an is 8 times an minus 1 minus 16 an minus 2. Now, How do we solve this? Anybody? What is our approach to solve this equation? What's the main idea? Well, look at this as equation and then you apply this, for example, there. Yeah. So that means let's check, right? So we check whether taking an as this expression would give us this. So right. So what is the left hand side? Left hand side is an. So we have an is equal to 8 an minus 1 minus 16 an minus 2, right? The left hand side is 2 times 4 to the power of n plus 3n 4 to the power of n is equal to, well, what about this one? Let's substitute the n minus 1 term. So that means 8 times, well, 2 times 4 to the power of n minus 1. Let us simplify this a little bit. So this is what we can do. Yeah. So this is in fact this is equal to 2 plus 3n times 4 to the power of n, right? So that means this becomes 2 plus 3n 4 to the power of n is equal to 8 times 2 plus 3n times 3n minus 1 times 4 to the power of n minus 1 minus 16 times 2 plus 3 n minus 2 4 to the power of n minus 2. Now we should simplify this. What about the left hand side? The left hand side is fine on the right hand side. The right hand side is actually, well, 16 times 4 to the power of n minus 1, yeah, plus 8 times 3n times 4 to the power of n minus 1, so 24n 4 to the power of n minus 1 minus 8 times 4 to the power of n minus 1. What about the right here? Minus 32 times 4 to the power of n minus 2 minus 48 n times 4 n to the power minus 2 plus, sorry, I think I made mistakes here. Yeah. So let's do it from the beginning, all right? Yeah, so let's just do it here. So here we know that the left hand side is 2 times 4 to the power of n plus 3n times 4 to the power of n. And the right hand side is 8 times 2 times 4 to the power of n plus 3n 4 to the power of n minus 16 n minus 1. Sorry. So what is an minus 1? An minus 1 is 2 to the power of 4 to the 2 times 4 to the power of n minus 1. So that means 8 times 2 times 4 to the power of n minus 1 plus 3n minus 1 4 to the power of n minus 1, right? And then plus, oh sorry, minus 16 an minus 2, right? So 2 times 4 to the power of n minus 2 plus 3 times n minus 2 4 to the power of n minus 2, right? Now, what about the right hand side? Yeah, so this is equal to 16 times 4 to the power of minus 1 n minus 1 plus 3n times 4 to the power of n minus 1 minus 3 times 4 to the power of n minus 1, and then we have minus 32 times 4 to the power of n minus 2 plus 16, 24, this is 20, this is minus, I always forgot this one, sorry. Yeah. So this is 16, and then we multiply them. So 24n times 4 to the power of n minus 1. Yeah. And then minus 24 times 4 to the power of n minus 1. And then you have minus 32 times 4 to n minus 2. And then you multiply this. So you have minus 48 times n times 4 to the power of n minus 2. And then minus 16 plus 2 minus 2. So that means minus, so it's a plus 96 for n minus 2, right? So can we reduce the right hand side into the left hand side, right? So that means so let me just erase this so it's not confusing. So the right hand side here, right hand side here, yeah, is this. Yeah. So now what about the left hand side? Left hand side must be, remember, left hand side is must be 2 times 4 to the power of n plus 3n 4 to the power of n, right? So that means we simplify that. Let's do it. So 16. So we combine them together. So essentially, this gives us, this gives us actually 4 times 4 to the power of n. Yeah. This one gives us plus 6n times 4 to the power of n, because you take out the 4 factor. Yeah. And what about this one? This is minus 6 times 4 to the power of n. What about this one? Minus, so you take out the 16, so you want to get so there is minus 2 times 4 to the power of n. Yeah. And then here you have, you take out the 16, you combine the 16 from 48 to 4 to the power of 4, so you get minus 3n times 4 to the power of n. And then this one, you take out the 16, that means you have 6, right? So plus 6 times 4 to the power of n. Now what we have is actually, this is 2 to the power of times 4 to the power of n plus 3n times 4 to the power of n. Yeah. So which is the left hand side. Yeah. Okay. So yes, this is yes. Yeah. Okay. Which one of you gets this correct? Got this correctly? Any question? No? If not, then let's move on. Let's check this. Yeah. Let's say the left hand side has to be to the power of n. Now what about the right hand side? The right hand side is of course, 8 an minus 1 minus 16 an minus 2, which is of course 8 times 2 to the power of n minus 1 minus 16 times 2 to the power of n minus 2. Yeah, yeah, n is this, yeah. So this gives us, of course, 4 times 2 to the power of n, yeah, minus 4, yeah, 4 times 2 to the power of n, which is 0, yeah, which is 0, right? So this is not equal to the left hand side. So this cannot be an answer. Yeah. What about the next one? Is the next one an answer or not? Which one of you choose this one? Nobody?
No, sir.
No. Okay. So, okay. We spend a lot of time on this. So let's just go through it, right? So minus 4 to the left hand side here. This one, yeah. The left hand side is an minus 4 and what about the right hand side? Right hand side is 8 an minus 1 plus minus 16 an minus 2, and we substitute the expression, so we get 8 times minus 4 to the power of n minus 1, yeah, minus 16 times minus 4 to the power of n minus 2. Now, careful with this one. How do we solve this? Well, let's see. So we take out, this is the same as 8 times minus 1 to the power of n minus 1 times 4 to the power of n minus 1 minus 16 times minus 1 to the power of n minus 2 times 4 to the power of n minus 2, right? So now this is equal to, no, this one, yeah, 8, sorry, 2 times 2 times 4 to the power of n times minus 1 to the power of n minus 1, yeah, and then minus, now we get there, so that means we need the 16, so 4 times 4 to the power of n, yeah, and sorry, not 4, it's actually 1, yeah. So yes, it's actually 1, yeah. So that means 16 times 4 to the power of n minus 2 is the same as, well, I think it's easier just to say it here. 16 is actually 4 to the power of 2, right? So 4 to the power of 2 times minus 1 times n minus 2, right? Now this gives us, of course, 2 times 4 to the power of n minus 1 times the power of n minus 1, and then this is minus, so it is n minus 2, right? So this gives us 4 to the power of n times minus 1 power of n minus 2, and at the end, well, this gives us, of course, what about this one? Well, this gives us actually, remember, minus 1 to the power of n minus 1 is the same as, so minus 1 to the power of n minus 1 would be the same as minus minus 1 to the power of n. Yeah, remember that, because if n is odd, then n minus 1 is even. Yeah. So you have that actually this is actually equal to minus minus of minus 1 to the power of n. Yeah, so that means this becomes minus 2 times 4 to the power of n times minus 1 to the power of n. Yeah, and then this one is equal to minus 1 to the power of n, right? Because if n is even, then n minus 2 is also even, right? So they have the same sign. So that means this is minus 4 to the power of n minus 1 to the power of n. Now you have that. That means now this is equal to, well, minus 2 times minus 1 times 4, so minus 4 to the power of n. Yeah. And this is minus 4 to the power of n. Now, this is so we cannot simplify this, yeah, because this is the same as minus 1 minus 2, sorry, you take out the minus 4 to the power of n, yeah, times minus 2 minus 1, right? So that is minus 3 times minus 4 to the power of n, which is not equal to the left hand side. So this is not our answer either. So you do the same thing for the rest, right? Yeah. You could check the details. You have checked whether left hand side is equal to the right hand side. You get the answer. All right. Unfortunately, we are running out of time. We will discuss the solutions for the homework on Wednesday. Sorry, for the what is it, the recurrence relation worksheet on Wednesday as well. Yeah, and we have and then we have one remaining week to talk about the recurrence relation. Sorry, the power series to solve the recurrence relation. All right, any questions so far?
No, sir.
No. All right, if not, then let me finish this and we'll continue again on Wednesday. Yeah, and then I'll see you guys on Wednesday.
Yes, sir.